Okay, Paldeep is there. Yes, Paldeep. Now,
The
good morning, all of you, and let's start our today's discussion. Before going for the discussion of a new topic, let's have a quick recall from Bhavdeep what we had done in our last session. Yes, Bhavdeep,
so
please.
the probability mass function is used for discrete quantities and probability density function is used for continuous quantities.
Okay, discrete quantities, continuous quantities. At that moment, you're using the word quantities. Can you replace that quantity word by any of the other technical terms of our subject?
The intervals.
Quantities, discrete random variable, is it? Continuous random variable.
Where
Okay. So in the last session, we were dealing with random variables, uh, discrete and continuous. Hopefully, I had delivered both that concept, what we mean by discrete random variable, what we mean by continuous random variable. And from today's lab, let me start my screen sharing. Now, hopefully, my screen is visible to all of you now. Am I live? Is it?
Yes,
Now it's
sir.
visible. Okay, Meghna. Had I delivered this particular definition, probability density function, ये मैंने करवा
Yes,
दिया था बेटा?
sir. Yes, sir.
Good. Okay. So as we know that random variable can be categorized in two different types: uh, discrete random variable and continuous random variable. A discrete, when we are supposed to deal with the discrete random variable, when we are interested in counting. Suppose I am counting number of cars, I am counting number of children, I am counting number of defective items. In all such manner, when we are counting some of the things, or in other words, when that particular random variable can take values, different values only, whether it is positive, negative, or zero, but it should be integer value. In all such cases, we are dealing with a discrete random variable. And when we are dealing with measuring some of the data, suppose measurement of temperature, measurement of height, measurement of weight, like that, measurement of blood pressure, in all such cases, we are dealing with a random variable in one of the particular interval. So measurements leads to measurement leads to continuous random variable, and counting leads to discrete random variable. Good. So the things are clear about the types of random variable. And after that, that might वो मेरी तरफ से नहीं था, don't know. Okay. After that, we had defined probability function. Even what we mean by probability function. Now, probability function can be defined for discrete as well as for the continuous random variable. Now, if we are defining a probability function for the discrete random variable, then such probability function will be known as a probability mass function. And if we are defining a probability function with the continuous random variable, then such probability function will be known as a probability density function. As simple as that. And for the probability function, we are actually interested in two conditions, two specific, what I can say, conditions. That conditions were something like that. Let me choose a pen. Yes, here is the pen. Let me check whether it is working or not. Okay, yes, it is working. Now it's working. And the conditions were that probability that a random variable, whether that random variable is continuous or discrete, for each and every value that x gonna assume, that probability must be lying in the interval 0 to 1. And the summation of addition auto integration, summation of all that probabilities of x should be 1. So both these are the initial conditions which a function gonna satisfy. In such a case, that function will be known as a probability function, is it? Now, that depends on whether we are dealing with discrete or continuous. If we are dealing with the discrete, then we will take use of summation. And if we are dealing with the continuous, in such a case, we will be using integration, because in this discrete in the continuous enumerable, we will be dealing with integral interval, one of the interval, and we know that in the interval there will be infinite values. So it's not possible to list out all that values of all the values which a random variable gonna assume, is it? So in such a case, we will be dealing with continuous random variable and integration. In the case of discrete, we will be using summation. Good. So let me give a quick recall of probability density function. Probability density function means continuous random variable. Let x be a continuous random variable. Then the function f of random variable x is called probability density function if all that probabilities must be lying between 0 and 1 for the interval minus infinite to plus infinite, and addition of all that probabilities. Here, the addition is represented by summation. For that particular interval, we are dealing with the interval minus infinite to infinite. So integration over minus infinite to infinite, f of x dx is 1. Earlier, in the definition of probability mass function, instead of this integration, I had just used the summation. So कोई measure different नहीं है, समझ में आ रहा है सभी को? And this is the way how we can find a probability for one of the specific interval. If I wish to find the probability for the interval 1 to 2, then it will be integration over 1 to 2 f of x dx. And one more thing I would like to add here, when I'm using that particular notation, when I'm using the notation f of x, what does it mean? ये सभी को पता रहना चाहिए. When I'm using this notation f of x का मतलब क्या है? We are dealing with the probability function. Or what does it actually mean? ये जो small x है, this small x is one of the value which our random variable x gonna assume. So small x is actually one of the value from the capital X, and by this f, we mean that probability that my capital X gonna take the value small x. That means we are dealing with the probability. So ये भी एक probability है. It must be clear in all of your mind. F of x is a probability. Okay, it is actually a probability function. So good. और इसके बाद हमने एक example भी किया था. Might be this was the example, is it, Meghna?
यस सर, ये भी किया था.
ये हमने खत्म कर दिया था कि बाकी था?
सर खत्म कर दिया.
ठीक है. And had I defined that probability density function? शायद ये नहीं किया था. Sorry, cumulative distribution function had I delivered?
हाँ सर, ये किया था.
Okay, what is cumulative distribution function in such a case? Can any of you will explain this in your own words? Any of you? What is cumulative distribution function? My question is as simple as that. Cumulative distribution मैंने cumulative frequency मैंने पहले आपको याद करवाया होगा last lab में, whenever I had delivered this, and after that particular cumulative frequency, उस concept के साथ मैंने attach किया होगा इस topic को कि what is cumulative distribution function. So we are dealing with two different kinds of random variable, discrete as well as continuous. So what is a cumulative distribution function for the discrete random variable, and what is the cumulative distribution function for the continuous random variable? आप में से कोई एक unmute करके बताएगा? Any of you? Or in other cases, I will be choosing a person randomly from the list. कोई एक. भवदीप बता सकता है बेटा तू? दिव्य, भवदीप, दिव्य, जानवी, इवांशी, विभूषा, सुशील. अरे कोई तो बात करो, मैं अकेला बात कर रहा हूँ क्या? हाँ यश तू बता.
सर कम्युलेटिव डिस्ट्रीब्यूशन फ्रीक्वेंसी तो वो होती है जिसमें अपन पुरानी फ्रीक्वेंसी भी ऐड करते जाते हैं.
हाँ हम ऐड करते हैं, इज इट ना? पुराने वाले के साथ नहीं ऐड
पुराने
करके
वाले के साथ नए वाले को ऐड करते लास्ट में टोटल हो जाता है.
यस 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 गुड. तो उसी हिसाब से एज आई नो दैट आई हैड डिलीवर्ड दैट, मैंने वो भी आपको रिकॉल करवाया था. अब उसी कंसेप्ट को लेके क्या आप कम्युलेटिव डिस्ट्रीब्यूशन फंक्शन याद कर सकते हो बेटा? व्हाट वाज द नोटेशन फॉर दैट? द नोटेशन फॉर द कम्युलेटिव डिस्ट्रीब्यूशन फंक्शन वाज कैपिटल एफ ऑफ एक्स, अगर आपको याद हो तो.
एफ ऑफ एक्स डीएक्स इंटीग्रेशन माइनस इन्फिनिटी टू इन्फिनिटी.
Not minus infinity to infinity. आप पहले तो कंटिन्यूस के लिए बोल रहे हो, then it is minus infinite to x f of x dx. It will be as simple as that. But if we're dealing with the continuous, sorry, discrete random variable, let me show all of you. Yes, if we're dealing with a discrete random variable where the discrete random variable gonna assume the value x1, x2, x3 in such a way that x1 is less than x2 is less than x3, like that, then capital F of xn, capital F of xn, here xn is one of the value which my random variable gonna take. So अगर मुझे cumulative distribution find करना है up to xn, तो मुझे क्या करना है, xn से पहले जो भी xn से छोटी जितनी भी वैल्यू है जो x अज्यूम कर रहा है, उन सारों की प्रोबेबिलिटी आइडेंटिफाई करके उसको ऐड करना है. इज इट? सो एज सिंपल एज दैट, नथिंग, इसमें कुछ ज्यादा बड़ी बात नहीं है. Suppose we wish to find for the discrete case, suppose we wish to find capital F of x2 or the capital F of x3. Suppose I am finding x3. तो x3 से छोटी जितनी भी वैल्यू है, मान लीजिए 3 है, x1, x2, x3. What I need to do? I need to add that probability of p of x1 plus p of x2 plus p of x3. That's it. So it is very, very easy. If I wish to go for f of x4, तो एक ऐड कर दूंगा p of x4 plus p of x4, like that. In that particular concept, in that particular understanding, now you can understand capital F of xn relates to p of x1, p of x2, p of x3, p of x4 up to p of xn. So this was the cumulative distribution function for discrete, as well as if we are dealing with a cumulative distribution function for the continuous random variable, then in such a case, first of all, let me erase all thing from the slide. Yes, this was the definition. Minus infinite to x. In that case, fx, capital Fx, capital F. Oh, please take care about the notation. When we are dealing with capital F, that means I'm dealing with cumulative distribution function. And if I'm dealing with small f, that means I'm dealing with probability function. Is it? And these are the standard notations. You cannot change that notation because each and every reference book is having the same notation. So take care for that. So capital F of x for the continuous random variable will be solvable using integration minus infinite to x. कहाँ तक जाना है? स्टार्ट करना है माइनस इन्फिनाइट से, जाना कहाँ तक है? जहां तक बोला गया है. Suppose I am finding f of x2, so minus infinite to x2. Suppose I am finding f of 3, then minus infinite to 3, like that. And in this case, f of t dt, यहाँ पे मैंने f of t dt लिखा हुआ है. It's totally okay if you are using the notation f of x dx, is it? So this is a concept related to continuous random variable and discrete random variable, and we were talking about CDF, माने कि cumulative distribution function. And I don't think so we had gone for any of the example related to CDF. CDF का कोई example नहीं किया था, हमने सिर्फ एक ही example किया था, that was this example 16, जिसमें हमने check किया था कि whether the provided function is cumulative is a probability density function or not, and if it is density function, then we were finding the probability that x gonna take value from the interval 1 to 2, is it? So ये पूरा हो चुका था, हाँ या ना मेघना?
यस सर. सर इसके बाद एक और एग्जांपल किया था हमने.
Is it this?
यस सर.
ये भी कर लिया था पूरा?
यस सर.
पूरा?
हाँ सर पूरा.
ठीक है, चलो आगे बढ़ते हैं. Let me take for example 18 and good. Now ये बाकी है मेघना, यहाँ से बाकी है, ठीक है?
हाँ सर.
Good. So today's session is mostly going to be a practice session for you guys, because at the end of example 18 as well, or might be I'm having 19, 20. इसके बाद दो example और हम लेंगे, and after that, after I am delivering next two examples, I'll be assigning two exercises to all of you, and will give you the appropriate time. That exercise is related to random variables, continuous, discrete. You need to check whether it is probability density function, probability mass function or not, and then some of the question related to the CDF, cumulative distribution function. You will be finding some of them on A or K, like that. So be ready with your lab book, because today's session is gonna be a practice for you guys, is it? The most of the content of this particular will be a practice session. But before that, let's discuss example 18. A continuous random variable x has following PDF. Now, what will be the PDF here? What is the meaning of PDF? PDF का full form क्या है?
Probability
But
density function.
Probability
yes.
distribution, sir.
तो कौन कौन बोला probability distribution? कौन बोला? एक रूल हमने फिक्स किया था लास्ट लैब में, अगर नहीं किया तो अभी कर लेते हैं. Look, I had joined this meet from two different devices. I'm using my laptop as well as I'm using my cell phone. Is it? So when I'm on the laptop, I will be not able कि भाई कौन बात कर रहा है मुझसे. So when you are interacting with me, when you are unmuting your mic, the first statement from your side should be like that. Hello sir, it's Bhavdeep here. Hello sir, it's Meghna here. Meghna here. And then you will be saying your line, is it? So take care for that because I will be not able to identify कि कौन बात कर रहा है. वो आइडेंटिफाई करने के लिए मुझे अपना सेल हाथ में लेना पड़ेगा और उसमें देखना पड़ेगा. So it will be good for me. नाम के बगैर आपके साथ बात करना मुझे अच्छा नहीं लगता. It's not good for me. Okay. So who was interacting with me? It's okay. कोई बोला probability distribution. कौन बोला बेटा?
Sir, Bhavdeep.
Yes, Bhavdeep. Yes, Bhavdeep. बात करो मुझसे.
Sir, probability distribution function.
Probability distribution function. अब सोच, मैंने ऐसा कुछ करवाया probability distribution function. हमने बात की है probability function की, is it? और फिर हम बात करेंगे इस सारे एक्सरसाइज के बाद, that is probability distributions. अभी distribution का इतना कुछ बात नहीं हुआ. We are gonna learn some of the spatial distribution. So here PDF stands for, as Meghna said, this is probability density function. Take care. Is it? क्योंकि बहुत सारे short form हम use करने वाले हैं, बहुत सारे initial हम use करने वाले हैं. So it must be clear in your mind. So probability density function, when we are using the word density, that means indirectly we are having one of the information that we are dealing with continuous random variable. Here x, small x will be a continuous random variable. क्योंकि continuous होगा तभी तो density बोलेंगे. If that random variable is discrete, then we will be using PMF. That PMF stands for the probability mass function. Mass discrete, density continuous. That is clear, is it? Now, continuous random variable x has the following PDF. मानी कि following probability density function. So this is probability density function. That is information we are having. That is our data. We are not going to check whether this is probability density function or not. Data में ही बोला गया है कि ये probability density function है. So we will be taking the data with ourselves. This is probability density function. Now, what we need to find? We need to find two constants a and b such that probability that x is going to take value less than a. Let me erase this because it's yes. Probability that random variable x is going to take value less than equals to a is equals to probability that x is going to take value greater than a. This is first information we are having. This is the data we are having. And second information is probability that x is having value greater than b, small b. That probability is 0.05. This is also the data we are having. Now, what we are supposed to find, we are looking for such type of a and b. So our main target is to identify the value of a and b from this using both these data. And we are having one more additional information that a and b both are lying between 0 and 1. A and b both are greater than 0 and less than 1. Okay, so this is the data we are having. Let me make the things clear a little bit more. Suppose this is my number line, and this is positive and negative infinite, and this is positive infinite, and as per the functions defined, this function is defined. It is provided in the data and probability function. This is one of the probability function. If my input, that means if my random variable x is lying in the interval 0 to 1, not 0, not 1, but between 0 and 1, then function will act as a 3x square, 3 times x square. And in all the other cases, function will act as a 0. So let me assume, suppose here, randomly pick 0 over the number line. This is 0, this is 1. Suppose this is 1. Now, between this particular interval, in this interval, my function is having a nature f of x equals to 3 times x square. And rest of all the cases, in rest of all the cases, in all the rest of cases, means all this case, यहाँ पे when my random variable x gonna take value greater than 1, f of x will act as a 0, and with the similar fashion ये भी जो पूरा इंटरवल है माइनस इनफाइनाइट टू 0 वाला, यहाँ पे भी f of x is 0. And two more additional information that a and b is lying between 0 and 1. तो a और b यहाँ पे कहीं पे है, पता नहीं कहाँ पे, that is not equidistance, ऐसा कोई information नहीं है हमारे पास, बस a और b इस इंटरवल में है, कहाँ है पता नहीं, a बड़ा है b बड़ा है, we don't know anything. Okay, so जब भी हम आंसर we will be easily able to verify answer a और b जो भी वैल्यू आ रही है that will be 0 point something, वो 1 point something, 2 point something, 3 point something नहीं आ सकती, because we are having data a and b both are lying in the interval 0 to 1. Good. And then this is the very, very crucial information we are having. Probability that x is less than equals to a and probability that x is greater than a. Both these probabilities are equal, and probability that x is greater than b is 0.05. So using these three data, this is the first information, this is the second and third. Using these three, we are going to identify our two unknowns, A and B. I can say a good question, a quality question from this topic. This will be, the discussion will be quite good. So, should I give you 2-3 minutes to try? क्या मुझे आपको 1-2 मिनट देनी चाहिए? आप विश के एक बार आप ट्राई करें, फिर मैं आपको सॉल्यूशन बताऊं, या आई शुड बी डीलिंग विद द सॉल्यूशन डायरेक्टली? एनी ऑफ यू प्लीज. क्या आपको टाइम दूं 1-2 मिनट का, या फिर मैं ही डिस्कशन कर दूं सॉल्यूशन का पूरा? वन ऑफ द कमेंट फ्रॉम योर साइड. दिव्य, ये यस सर का क्या मतलब होगा? आपको टाइम चाहिए कि या तो फिर मैं डिस्कस कर दूं? क्या बोल रहे हो क्या दिव्य आप? दिव्य
टाइम चाहिए.
हाँ चलो 2 मिनट देता हूँ, चलो. एंड आई विल बी रैंडमली चूजिंग द पर्सन. प्लीज 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 ट्राई वंस. इट विल बी गुड फॉर यू गाइज. इवन एक बहुत अच्छा कॉन्फिडेंस बिल्ड होगा अगर आप खुद से सॉल्व कर सकते हैं तो. सो आई एम गिविंग यू 2-3 मिनट्स. इट्स नॉट दैट मच टफ. Okay, Pradeep is saying doing so. Okay, I'm writing. So, uh, should we discuss the solution now? Okay, one of the answer is from A is 1/2 raised to 1/3. 1/2 raised to 1/3. Divya, might be your answer is correct. Cube root of 1/2. Correct. What about B, Divya? भवदीप आपने किया, मेघना आपने किया बेटा, इवांशी, निधि, विभूषा, मोहम्मद, अरे मोहम्मद केफ भी तो है. Mohammed, are you there? Are you attending the session or not? Divya, look. Now you can verify your answer. Divya, your answer is B equals to 1.016. Now you can just check one of the condition. We are having one of the condition that A and B must be between 0 and 1, is it? And you are saying that B is 1.016. So mathematically it will be not possible. बिना चेक किए मैं बता दूं कि आपका आंसर गलत होगा. तो बी के कैलकुलेशन में कुछ थोड़ी सी गड़बड़ कर दी आपने शायद. Try it once more. Yes, Mohammed. You were saying something, Mohammed? Okay, Mohammed just joined. Shushil, are you there? Shushil Prasad? Shushil Prasad? Shushil Prasad? विभूषा?
यस सर.
हाँ सुशील, तूने की है बेटा, ट्राई की?
सर ट्राई कर, अभी सॉल्व कर रहा हूँ.
दिव्य जोडेजा, दिव्य यू आर सेइंग b इक्वल्स टू 1.016. वो नहीं हो सकता बेटा, b की वैल्यू. यस, नाउ यू आर सेइंग b इज 0.983. लेट्स चेक वेदर you are correct or not. Yes, someone was saying, might be Mohammed was there. वो चला गया. Might be some of the network issue from his side. ओम परिक, बेटा आपने की, ट्राई की बेटा. ओम परिक.
सर कर रहा हूँ सॉल्व.
अरे इतना टाइम तो नहीं लगेगा अगर तुझे समझ में आ गया है तो. ओके. निधि जैन, आर यू देयर? निधि, निधि, डन विद बोथ दैट क्वेश्चंस, बोथ दैट अननोन ए एंड बी. मिले कि नहीं मिले बेटा अभी तक, कि ट्राई नहीं की अभी तक? विभूषा, क्या आंसर आ रहा है बेटा ए बी का?
Sir, I got the A, but B, I'm still trying.
ओके, स्टिल ट्राइंग. ओके. कृणाल चौहान, कृणाल, 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 आर यू देयर? ओके बेटा, हैव यू गॉट द आंसर फॉर ए एंड बी? मिल रहा है आंसर कि नहीं मिल रहा है? Yet you are trying, let me know your status. I'm still trying. इसका मतलब तो ये हुआ कि मैं ठीक से पढ़ा नहीं रहा हूँ, यही मतलब निकल रहा है. ईशा, ईशा डडानिया, unmute yourself and talk to me.
Yes, sir.
Are you able to get the value of A and B from the interval 0 to 1?
सर ए का हो गया, बी का ट्राई कर रही हूँ.
बताओ ए का क्या आंसर आ रहा है?
क्यूब रूट ऑफ मींस 1/2 रेस्ट टू 1/3.
ओके, रेस्ट टू 1/3 बोल रहे हो तो क्यूब रूट नहीं बोलना है. रेस्ट टू 1/3 इज इटसेल्फ द क्यूब रूट, इज इट?
ओके, सॉरी सर.
हितेश कृपलानी, मेघना तू बता दे, चल बेटा. क्या आंसर आया ए बी दोनों का?
सर मैं ट्राई कर रही हूँ, मुझे ना एक्चुअली इसकी कंडीशन नहीं मिल रही कि इंटीग्रेशन में क्या लिखना है.
ओके ओके, आई नीड 1 मिनट. अभी एक और मिनट देता हूँ आपको जल्दी. So now let me show the solution. Yes. Since the probability is 1, we know that as the provided function is probability density function, that means it is a probability function. And if we're dealing with a probability function, then addition of all the probabilities must be 1. So now what we are doing right now, we are dividing that specific interval from minus infinite to infinite into two category, minus infinite to a to positive infinite. Now, as we know that probability of both that parts are same, that probability that x is less than equals to a, as well as probability that x is greater than a. Now, as we know that both these are same, that means both these will be having equal probability. That means कोई एक भी ले लो, x greater than a ले लीजिए या तो फिर x less than equals to a ले लीजिए, उसकी probability 1/2 होगी. अब if you are good with this particular, अगर ये बात समझ में आ रही है ना, तो ही then and then you will able to understand the rest of the solution. So यहाँ पे जो मैंने लिखा है, the way I had written over here, where's my pen? Yes, here it is. Now this step is very, very important. So first, let me know whether you guys are clear with this particular step or not. अगर ये बात समझ में नहीं आ रही, then I will be explaining this by some of the other words. Are all of you able to understand this particular? Yes, it's clear, sir. देखिए मैंने क्या किया हुआ है, देखिए जिन लोगों को समझ में नहीं आ रहा उसको एक बार समझा दूं. I am having one of the number line over here that is minus infinite to infinite. And as we are having information that my f of x is probability function, that is our data, is it? Then the integration running from minus infinite to infinite f of x dx will leads to 1. ये तो पक्की बात है, because this is one of the condition for the probability function, and we are dealing with continuous, so it is probability density function. It's okay. Now what I'm doing, I'm just dividing. Just forget about 0, just forget about 1, forget about b. Let's assume one of the a over here. Suppose कि ये यहाँ पे कहीं है, और बीजी दूसरी एक बात हमको ये पता है, one more thing is a is gonna lie between 0 and 1. 0 के 1 के बीच में कहीं पे होगा. कहाँ है? We don't care for that. Exactly middle है या तो near to a, near to 1. Don't worry about that. But a will be somewhere between 0 and 1. Good. Now using that particular point a, I'm dividing this line, this interval, minus infinite to infinite into two parts. उस हिसाब से एक हिसाब से इसको मैं दो पार्ट में डिवाइड कर रहा हूँ. Let me choose the color. Yes, we are dividing that into two parts, minus infinite to a, and second that is a to positive infinite. Now what are the information we are having? One of the information we are having is probably that x is greater than equals to a, and probably that x is less than equals to a, and probably that x is having value greater than a. ये दोनों सही, ये दोनों इक्वल है, और ये पूरा एडिशन 1 होगा, ये भी पता है. So it means what? It clearly indicates that both that probabilities will be half. So you may deal with this part or you may deal with this part. What I'm doing, I'm dealing with the positive part. So I'm dealing with this particular, that probability that x gonna take value greater than a is 1/2. So with that particular logic, I started with this. Probability that x is greater than equals to a, less than equals to a is 1/2, as well as probability that x is greater than equals to a, that is 1/2. Now if x is greater than equals to a, that probability is 1/2. That means I can express like that, that probability that x is greater than equals to a, उसको लिखते कैसे? Probability that x is greater than a, and in the annotation, using annotation, it should be written like that: integration running from 0 to a, f of x dx equals to half. Now, but why 0 to a? Why 0 to a? I must be writing like from a to infinite, is it? So observe, उसका भी एक logic है. Actually it is like integration over a to infinite f of x dx equals to half. F of x dx should be half, as per the discussion we had. Sorry. What's wrong with my screen? Now will be fine. ये होना चाहिए a to infinite f of x dx equals to half. But For a to infinite, I need to divide that integral into two parts once again. A to 1, 1 to infinite. Why I'm dividing that? Because I'm having my function in that way. 0 to 1 के बीच में जो भी वैल्यू है उसका आउटपुट होगा 3x square, and for rest of all the cases output will be 0. So I will be not able to assign f of x in this interval a to infinite. A to infinite में f of x में ऐसा नहीं कर सकता. तो for that I need to divide this particular into two integrals once again. That two integrals will be, let me erase some of the data, some of the, yes, let me erase this. Now I'm dividing this interval into two parts like this. Integration over a to 1 plus integration over 1 to infinite. Is it? So ये क्या हो गया? A to infinity हो गया, A to 1, 1 to infinite. Now might be there is one question in your mind, sir, whether A will be less than equals to A or not. A 1 जो है वो A से पहले आएगा बाद में आएगा, तो वो तो यहाँ पे क्लियर है. We are having that information. A is smaller than 1. So this sequence is proper. A to 1, then after 1 to infinite. Now for this part, A to 1, my function will having a nature 3x square dx. For this part, 1 to infinite, my function is having nature 0 dx. Is it? So look, using this, I'll be dealing like this. Is it? या तो फिर 0 to a. Okay, 0 to a भी कर सकता हूँ, वो भी ठीक है. Now solving this, 0 to a 3x square dx 1/2, that will leads to 3 times the integration of x square, it will be x cubed by 3. 3 will be constant as it is. So putting both that limits 0 to a, upper limit a is a cubed by 3 minus, if I'm replacing 0, then it will be 0 by 3, it will be meaningless. So solving that, we will be having a cube equals to half, and a will be the cube root of 1/2. Now, are we clear with these things? क्या ये बात समझ में आ रही है? The similar way I had used that 0 to a, ये part भी मैं use कर रहा हूँ. Answer will be same. यहाँ पे जो explanation है, that is for this part 0 to a. Or if we are using this part, in that case also, your answer will be 1/2 raised to 1/3. That means cube root of 1/2. So both this will leads to the same answer. So our A is 1/2 raised to 1/3. So are we clear? क्या ये बात जो मैंने अभी की वो समझ में आ रहा है कि नहीं आ रहा है? Yes, yes, Bhavdeep is saying perfect. Bhavdeep जो बात कर रहा है वो सही है, ठीक है. Good. Now let me erase the ink and let's try to find the value of B. So I'm erasing all the ink from the slide and let me show how I had calculated B over there. Once go through this and let me know whether क्या अब आपको समझ में आ रहा है कि नहीं आ रहा है. As we know that probably that x is greater than B is 0.05 and we are knowing B is less than 1. So we must be interacting with the interval B to 1. And for the interval b to 1, that is interval b to 1 will be the subset of interval 0 to 1. So for the interval b to 1, f of x will act as a 3x square. So that is the reason why I had written 3x square over there, because interval b to 1 is the subset of interval 0 to 1. So 3x square will be the integrand for that particular, and using the same integration, 3 will be as it is, x square will get integrated into x cubed by 3 over the limit b to 1, replacing both that limits. We'll be having b cube equals to 19 by 20, or you may deal with the fraction even 0.95 like that. ऐसे भी बात कर सकते, and that will be cube root of 0.95. Is it? So that was one of the answer might be in the chat box. किसी एक ने ये आंसर दिया था शायद. I'm not sure किसने दिया था, लेकिन okay, good. जिसने भी दिया हो, we are not worried about that. But are we clear with these things? Are we good? समझ में आ रही बात सभी को? I need reply from all of you.
यस सर. सर वो फर्स्ट क्वेश्चन में हम वो कंडीशन यूज करके भी कर सकते हैं p
हाँ,
ऑफ
A to
x
1.
ग्रेटर देन.
हाँ, वो भी कर सकते हैं.
नो सर, a to 1. हाँ, a to 1 तो भी सेम ही आंसर आएगा.
सेम ही आएगा बेटा. You may try. It will be same. 1/2 cube root of 1/2. Is it? किसी को डाउट? विभूषा is saying clear, सुशील is saying clear, मेघना clear. 3-4 लोग को समझ में आ रहा है. मोहम्मद, are you there? Mohammed, are you attending the session or not? Divya is saying good. Kunal. Nidhi, good. Parthi, good. So now let's deal with one of the example related to probability function की तो बात की हमने. Let's deal with the cumulative function. Cumulative distribution function का कोई example अभी तक नहीं लिया. So next might be we will be dealing with cumulative distribution function. Yes, here it is. Once again, a good question, a quality question. Now be with me. Let me make all of you understand about the question. Before that, let me choose my pen. Yes, this is my pen. Good. A discrete random variable x. Discrete, look, it's clearly mentioned that we are dealing with a discrete random variable. That discrete random variable is assuming the value -3, -2, -1, 0, 1, 2 and 3. ये सात ही वैल्यू ले रहा है हमारा discrete random variable right now. So our discrete random variable x takes the value -3 to 3 such that now these are the conditions, such that probability that x is equals to 0, probability that x is greater than 0, and probability that x is less than 0. Now these three probabilities are same. x या तो 0 वैल्यू ले रहा है या तो 0 से बड़ी माने कि पॉजिटिव. If x is gonna take values less than 0, these three probabilities are literally same. Now take care for this particular, when I am saying probability that x is less than 0, इसका मतलब क्या हो रहा है? x 0 से कम जितनी भी वैल्यू है, whether x gonna take value -3, whether x gonna take value -2, whether x gonna take value -1, this 3 will be included in this p of x less than 0, is it? Similarly, when I'm dealing probability x is greater than 0, that means I'm dealing with p of 3, p of 2, p of 1. Is it? Instead of writing this p of 3, you might be using this notation p of x equals to 3. I'm good with that. Okay. So both these are the valid notation. And the third is p of x equals to 0. So ये तीनों same है. Is it? These three are same. P of x is less than 0, P of x is greater than 0, and P of x is equals to 0. These three probabilities are same. This is our first data. And what is the second one? The probability that P of x equals to -3, -2, -1, 1, 2, and 3. Observe in this list we are not having 0. P of x equals to 0 नहीं है यहाँ पे. x -3 ले या तो -2 ले या तो फिर -1 value ले या तो फिर 1, 2 and 3 value ले. These 6 probabilities are also same. Now, using both this data, what we are supposed to find? We are supposed to find probability distribution. Probability distribution के लिए क्या करना है? X की वैल्यू नीचे P of X, is it? एक टेबल बनाना है पूरा. That's all. जो X जितनी भी अलग अलग वैल्यूज ले सकता है, अभी हमारे पास है -3, -2, -1, वो सब हम फर्स्ट रो में लिखेंगे. Respective probability will be in the second row. So that will be known as a probability distribution. We all know that. And after that, if we are having probability distribution function, then we will go for the cumulative distribution function. That means कि इस table में we will be adding one more row, and that row will be having a label f of x. So f of x, capital F of x हम यहाँ पे add करेंगे, और जो भी probabilities है p of x वाली, we will be adding that. So that is our task for this question. Might be question is clear to all of you. Am I clear with the question? Am I clear with the question? Hello? Are we clear with the question? Okay, good. So I think so you will be, आप सभी को इसके लिए try करना ही होगा because this is quite easy. So without asking you, I'm assigning you 3-4 minutes. Quickly go through it, and now please be serious because I will be asking one of the student from the list, and if he or she is not able to share that solution, in such a case I will be not able to assign the present. Is it? Take care. चाहे आंसर गलत हो कोई बात नहीं, मुझे कोई प्रॉब्लम नहीं. आंसर गलत है तो गलत है. It's okay, fine, we are good with that, but at least you should be trying. Okay, good. So your time starts now. I'm giving you 3 minutes quickly. So should we go for the solution? Should we go for the solution? Let me erase all the ink from the slide. Yes, now. Are we good? Divya. Then after, no, not. Yash, unmute yourself. Talk to me. Yash,
Yes, sir.
how's you fine?
Yes, sir.
If I'm gonna take and if I'm gonna discuss with you, then surely I will be having answer. We guys will be having answer because you are very, very good with your statistic. So wait. I'm not gonna take your turn. Let me choose some of the other person. Bharti, are you there? Bharti Kumari, are you attending the session? Bharti. Bharti. If you're not able to unmute yourself, then please acknowledge over the chat box. Bharti. Look, this is not acceptable. Meghna, once let me know when she is once again here, okay? Bharti is
Sir,
here,
she
yes.
replied in the chat box.
Yes, Bharti. Can you unmute yourself, beta? Are you in position to talk with me? Have you solved this question? I'm unable to unmute. It's okay. Can you share your screen in such a case? Are you able to share your screen? पहले तो ये बताइए आपने क्वेश्चन सॉल्व किया कि नहीं किया? Honestly, have you tried or not? Bharti, I'm talking with you. Have you tried for this question or not? Honest reply. I just need honest reply. If you're not of the question, then it's okay, but just let me know ताकि हमारा टाइम वेस्ट ना हो और हम आगे बढ़े. किया है नहीं किया ये बता दीजिए जल्दी से. Bharti. Yes, sir. Okay, then in such a case, what is your answer? What will be the value that probability x equals to 1? X p of x equals to 1 की वैल्यू क्या आ रही है इतना बता दीजिए चलिए. What is the probability that x is equals to 1? He's not replying now. Okay, Jay Dakan. Sorry. Jay, are you there? Kunal Chauhan, are you there? Kunal Chauhan, are you there? Okay, what I'm doing, I'm just removing all the other students. Mohammed, are you there? Mohammed. Am I audible properly, Meghna?
Yes, sir.
सर आंसर आ गया. कैन आई शेयर?
नहीं, यस रुक जा. तेरा तो आंसर सही होगा बेटा. मुझे देखना है कितने लोग अटेंड कर रहे हैं, बाकी के सारे क्या सो रहे हैं. मोहम्मद है यहाँ पे? मोहम्मद, are you there? Mohammed, are you there? Let me remove him. Nidhi Jain, are you there? Nidhi Jain.
Yes, sir.
हेलो सर. हेलो
हाँ,
सर.
तो मोहम्मद क्यों आंसर नहीं दे रहा बेटा? कब से तो पूछ रहा हूँ तेरा नाम, कब से तो ले रहा हूँ.
नहीं सर अभी मैं जस्ट नीचे गया था, उससे पहले सर मेरा नेट ही कनेक्शन खराब हो गया, तो मैं चेंज करके सर थोड़ी देर बाद आया हूँ.
ठीक है, तूने ये आंसर सॉल्व किया कि नहीं किया? क्वेश्चन सॉल्व
नहीं
किया
सर
नहीं
अभी
किया?
नहीं.
हाँ रुक जा, चलो अब देखना सोल्यूशन. यहीं पे रहना, जाएगा कहीं?
नहीं सर कहीं जाऊँगा नहीं.
विभूषा, you there? विभूषा is not replying since morning, might be. विभूषा बात नहीं करी वो हमसे. विभूषा you there? विभूषा राबड़िया. प्रियंक
Yes, sir.
सियानी. ओके विभूषा, आपने क्वेश्चन सॉल्व किया?
So I'm having still doubts in discrete.
ठीक है चल यस तू और मैं ही डिस्कस करेंगे चल बोल बेटा यश unmute yourself and let's discuss the solution how we can solve this question
-3 वो सारे जो इक्वल दिए है उसका आंसर आ रहा है 1/80
क्या हम करेंगे p of x equals to 0
x equal to
p of x equals to greater than 0 and probably that x is less than 0 is this 3 are same that means let's assume that is k one of the unknown k
और तीनों का सम 1 होगा
yes it should be 1 so k plus k plus k 3k should be
1/3 yes
that means k must be 1/3 is it
3 yes
means what the probability for this particular should be 1/3
yes
similarly this will be 1/3 and this part will be having the value 1/3 so p of x equals to 0 mil gaya yahan se that will be 1/3 good now we are having one more information that this 6 probabilities are same
yes
so usme se just earn one more information that p of x greater than 0 is 1/3 is it
yes yes
now p of x greater than 0 mani ki p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 will be 1/3 and one more information this 3 are same so let us assume that that is a so a plus a plus a it will be 1/3 that means 3 times a will be 1/3 that means a will be 1/9
yes
that means this all this all these values will be having 1/9 good
right
is it so it was very easy very understandable so let me resolve the ink and then let me show the solution the way you are supposed to present in the examination is it this should be the proper way this is the solution for the case now once go through this and it is literally same as we just discussed earlier I had chosen k and a here in this solution I am using the notation k1 and k2 so once go through this particular solution and let me know whether you guys are able to get this or not that probability that x equals to 0 will be 1/3 and the rest of all the probabilities which are same rest of all the probabilities for -3 -2 -1 1 2 and 3 is 1/9 so let me know the chat box if you guys are clear with this or not if you are clear then we will be dealing with the next part of this question that we will be finding probability distribution and cumulative distribution are we good with the solution किसी को डाउट है तो बता दीजिए जल्दी से let's go through this quickly so might be you guys are clear good so let's go for the next part now before going for next part कैसे करेंगे now we are looking for probability observe we are in need of probability distribution and cumulative distribution is it so probability distribution कैसे करेंगे look जाओ let me choose the pen first yes and now let me choose the screen and the black screen good so what we are doing we are dealing with the random variable x discrete random variable for that random variable we are looking for the probability distribution so probability distribution के लिए हम क्या करेंगे x की सारी जो values है उसका list बनाएंगे -3 then after -2 then after -1 then after 0 and 1 and 2 and 3 is it these are the values my x discrete number x can assume and then after probability distribution that small x equals to x for the -3 -2 -1 and 1 2 3 that value is 1/9 as we just solve that 1/9 1/9 1/9 and this 6 1/9 1/9 1/9 and we are knowing that probability that x equals to 0 was 1/3 so this is what this is a probability distribution ये हो गया हमारा probability distribution, is it? And one more thing we are supposed to find for this question, that we are looking for cumulative distribution function. Now, cumulative distribution function is labeled with capital F of X. This is the notation for the cumulative distribution function. So now for the cumulative distribution function, we need probabilities that we are already having in the second row. Is it? Now, what we are supposed to do for capital F of X, we just need to add all that cumulatively. 1 by 9, the 1 by 9 will be here. Now, addition of both this, 1 by 9 plus 1 by 9, it will be 2 by 9. It will be here. 1 by 9 plus 1 by 9 plus 1 by 9, it will be 3 by 9. I'm sure it is 1 by 3, but it's okay. It's 1 by 9. 1 by 9, 1 by 9 plus 3 by 9, it will give us 6 by 9. Then it will be 7 by 9, then it will be 8 by 9, and last it will be 9 by 9, meaning 1. So this will be this all table will be known as cumulative distribution function, capital F of X. And if we're dealing with just first two row, then it is known as a probability distribution. And you may deal like that. This is discrete probability distribution because we are dealing with discrete random variable. So hopefully we are clear. Let me show the solution. कैसे लिखना है? Yes, a probability distribution and distribution function will be like this. यही तो मैंने अभी बताया. देखिए, this is literally same, is it? So this is a solution for the example number 19. Let's move for one more example, last example of the today's decision, and we will be dealing with exercise. Now, find the constant k such that the following function f of x is PDF. PDF stands for the probability density function, continuous wala case. We are supposed to find one of the unknown k such a way that okay, we are supposed to identify unknown k such a way that this function is probability density function, and also find the cumulative distribution function f of x, and probably that x is lying between the interval 1 to 2. So this is the next question. Now, earlier we were dealing with the discrete random variable. Now we are dealing with the continuous random variable. अब इसके लिए भी आपको एक unknown k identify पहले करना है. After getting that k, we'll be dealing with a cumulative distribution and one of the random probability of one of the intervals. So once again, I'm giving you 2-3 minutes, not 2-3 minutes. You will be in need of at least 4 minutes. Once go through this particular, we're not gonna check whether it is probability function or not. That information we are having. ये probability density function है ही है. वो check नहीं करना है. This is provided is probability density function. उस डेटा का यूज करके हमको ये अननोन k आइडेंटिफाई करना है. वी आर लुकिंग फॉर दिस पर्टिकुलर k की. अगर ये प्रोबेबिलिटी डेंसिटी फंक्शन है तो व्हाट विल बी द वैल्यू ऑफ k, इज इट? सो फर्स्ट ट्राई टू आइडेंटिफाई k, देन वी विल बी डीलिंग विद कम्युलेटिव डिस्ट्रीब्यूशन. सो फर्स्ट अभी तो सिर्फ आपको k ही आइडेंटिफाई करना है. आई एम गिविंग यू 3-4 मिनट्स. quickly take your time and identify k. Yes, those who are saying k equals to 1 by 9, you're absolutely correct. Yes, yes, yes. Almost all of you are correct. So let me show the way I had solved that question. As we know that f of x is probability density function, and we are using one of its basic property, that minus infinite to infinite, that whole integration will end to 1. So minus infinite to infinite f of x equals to 1. And what I need to divide that integral into 3 parts. Why I need to divide that integral into 3 parts? Because my function is defined in the way like this. If I'm dealing with minus infinite, suppose this is a number line, this is minus infinite n, positive infinite n, and this is 0 and this is 3. In between 0 and 3, my function is having a definition f of x equals to k times x square, is it? And in rest of all the cases, in rest of all these cases, whether my x is less than 0 or whether my x is greater than 3, in all that cases, my function will gonna act as 0. F of x equals to 0 in this case, as well as in this case, f of x equals to 0. So I'll be literally interested in this interval only between 0 and 3. So this integration minus infinite to infinite will be divided into 3 parts, minus infinite to 0, then after 0 to 3, and 3 to infinite. And both this 3 to infinite and minus infinite to 0 will end with 0, because in that case my integrand is 0. So this will be 0, there will be no more. So just a simple single integration 0 to 3 f of x dx, and this for this interval f of x is having a value k times x square. Integrating that will be having k x cubed by 3 over the limit 0 to 3, and solving that we will be and with k equals to 1 by 9. So good. Once we are having a k, unknown k, then what I'm supposed to do, I'm supposed to modify my function. Earlier my function was f of x equals to k times x square. Now I'm having the value of k is 1 by 9. So now onwards my function will be labeled as 1 by 9 times x square for the interval 0 to 3, and for rest of all the other cases, function will act as a 0, is it? So this is our modified function now. This is our probability density function. Now what we are supposed to find next, we are looking for cumulative distribution function. Now cumulative distribution function for the continuous random variable is having the definition something like that. Capital F of x is equals to minus infinite to x. Take care for that, minus infinite to x. And earlier in the definition, I had mentioned that f of t dt, but we are not worried about the t or x. So we may use f of x dx because we are dealing with a definite integral. So यहाँ पे कौन सा variable ले रहे? It will not gonna change anything. So minus infinite to x f of x dx. Now just care ये करनी है, ये x और ये x दोनों लगे. Okay, minus infinite to x f of x dx. ये एक छोटा सा इंटीग्रेशन जो होगा, that will lead us towards the cumulative distribution function. अब वो कैसे करेंगे? Let me show you. F of x, cumulative distribution function f of x is minus infinite to x f of x dx. You may write f of t dt. I'm not worried about that. Okay, f of t dt भी लिखेंगे तो भी चलेगा. Good. Now minus infinite to x, that interval will be further categorized into 2 parts, minus infinite to 0 and 0 to x, because I'm not sure whether x is greater than 3. Okay, we are knowing that x is less than 3, but as per the data provided in the question, that my function is having two different kind of output, whether it is less than 0 or it is greater than 3, then on all such cases f of x will act as a 0, and in between the interval 0 to 3, function is having some other definition, that is 1 by 9 times x square. So I need to divide that into minus infinite to 0, 0 to x. Now this will be 0 because minus infinite to 0 वो part में तो वो 0 है, and rest of the case it is 1 by 9 x square, and by the simple definition it will be 1 by 27 x cube by the simple calculation. So this will be my cumulative distribution function. Now what about the next part? Can you try the next last one? Probability that x is between 1 to 2. Yes. One answer from your side. Wait, I just need 1 minute. I'm having one of the call. So as we are looking for the probability that x is lying between the interval 1 to 2, we just need to deal with a small integration from the for the limit 1 to 2. Lower limit will be 1, upper limit will be 2, and we know that the interval 1 to 2 is a subset of the interval 0 to 3. Is it now? As we know that interval 1 to 2, let me choose my pen first. Yes, here. We know that interval 1 to 2 is clearly the subset of the interval 0 to 3. And why I'm talking for this, because I'm having my function defined for the interval 0 to 3. 0 to 3 के लिए मेरे पास function define है और 1 to 2 उसका subset है, तो उसके लिए भी same function ही होगा. That function was 1/9 times k square. So I'll be using that once again, and the similar kind of integration will end with the digit 7/27. So this is 7/27 is the probability for random variable x is going to take value between the interval 1 to 2, is it? So this is the probability for one of the random interval. With the similar fashion, you can deal with the probability distribution function as well as probability for the one of the random interval, and you may identify whether the provided function is probability density function or not. So these were some of the basic examples we were supposed to cover. Now, let me know if you all are clear with the concept, today's concept. We will be switching over to one of the practice session quickly, and we'll give you just 2-3 simple questions for today's practice. But before that, please acknowledge whether we are good with this question or not. Are we good? Let me know the chat box. Till the time, let me find that PDF also. Yes, almost all of you are saying we are clear, we are good. So what I'm doing, I'm sharing. Okay, Meghna, हमने exercise 3 पूरी नहीं की थी ना? Might be we had just deal with the first 3 question in the exercise 3. Is it? Yes or no?
Yes, sir.
और उस एक्सरसाइज का सॉल्यूशन मैंने आपके साथ शेयर किया है कि नहीं किया व्हाट्सएप ग्रुप में?
नहीं किया आपने.
नहीं किया ना? गुड. So all of you are having your exercise 3 with you over your WhatsApp group. हमारा जो WhatsApp ग्रुप है उसमें मैंने एक एक्सरसाइज शेयर की थी लास्ट वीक में. Be on that exercise 3 and let me share on the screen also. I'm sharing the same exercise. Window exercise 3. Yes. Now on the screen you're having exercise 3. Now observe, in exercise 3 the first 3 questions we are already done. We're already done with the first 3 questions, that is related to total probability and Bayes theorem, and one of the part was there that was labeled as a homework. Yes, there it is. Example 4 and 5. Example 4 and 5. Let me just go through it quickly. Now, what is example 4? Verify. We need to verify whether the following functions are probability mass function or not. Probability mass function, that means for each and every case we will be dealing with the discrete random variable for all that 4 sub questions. So we just need to check whether the provided 4 functions are probability mass function or not. That is example 4, question number 4, and for question number 5. Once again, I'm dealing with the discrete random variable, and I need to identify this is the probability distribution in the table, and I need to identify the value of A from this. यहाँ पे देखिए आप एक unknown A है probability में. First, we will be finding that A, that is our first part, and second, we will be looking for the probability that X is lying between 0 and 5, and then we'll be looking for that X is less than equals to 6. That's it. So बहुत छोटे question है. Might be you will be just need 5-6 minutes. हर एक question 1 मिनट में आप कर सकेंगे. बहुत जल्दी से कर लीजिए. They should be in your lab book which we are maintaining with us. ये lab book में होना चाहिए. But अभी के लिए मुझे जल्दी से आंसर देना है बिकॉज वी आर हैविंग जस्ट 15 मिनट्स। तो जल्दी से आई एम गिविंग यू 5 मिनट्स, जल्दी से सॉल्व कर दीजिए। सिर्फ हम डिस्कशन सॉल्यूशन डिस्कस करेंगे, फिर आगे बात करते चलिए, ठीक है। सो
सर ये कंप्लीट कर लिए हैं तो
अभी
कैन आई शेयर इट?
सभी ने कंप्लीट कर लिया तो
नहीं सभी ने नहीं की, मतलब आप
यस
टाइम
यस यस,
बोला
तू
था।
वेट कर ले बेटा, तू वेट कर ले, तू वेट कर ले, ठीक है। बाकी सब की सारों की बाकी है।
वो फिफ्थ वाला भी करना है?
हाँ बेटा, फिफ्थ वाला भी करना है। अगर वो बाकी है तो तू वो कर ले जल्दी से। लेट मी स्टॉप द रिकॉर्डिंग बिकॉज़ वी आर डन विद द कंसेप्ट।